Welcome to the third tutorial video on the topic surd. So in this video, we'll go through rationalization of surds. My name is Ibrahim Ofori, and I will show you how to rationalize surd in this video. So let's start. Definition. So rationalization of surds is the process of making either the numerator or denominator of a fractional surd rational. Okay, so the surd should be in a fraction form. Okay, so process. We wanting to rationalize either the numerator or denominator. This is how we do it. We multiply both numerator and denominator by the conjugate surd of the denominator when you want to rationalize the denominator. Cool, right? So if you want to rationalize the denominator, we find the conjugate surd of the denominator, like here, conjugate surd of the denominator. Then after that, we multiply the conjugate surd of the denominator by both numerator and the denominator of our original fractional surd. This happens when you want to rationalize the denominator. Okay, so same applies when you want to rationalize the numerator. So if you want to rationalize the numerator, you find the conjugate surd of the numerator. After that, you multiply by both numerator and denominator of our original fractional surd. But we will stick to what? Rationalizing the denominator in this course. So in this our course that we are studying, our main course is to know how to rationalize the denominator. But if in case you meet it anywhere that you're supposed to rationalize a certain set or rationalize the numerator of a set, and you know how to do it. So let's solve examples so that you understand. Examples: rationalize the following sets. So I have the first one to be 3 square root of 2 over 5 minus square root of 2. How do we do this? Okay, you solve it and you understand. The second one is 1 over the expression 4 minus square root of 5. Third one is square root of 3 minus square root of 2 all over square root of 3 plus square root of 2. And the last one is 1 over the square of 1 minus square root of 3. Or you can say 1 over the expression 1 minus square root of 3 all squared. So how do we solve this? Okay, let's start with the solution. So the process is that you are supposed to find, here you want to rationalize the denominator. When they leave it like this, that rationalize the following set, what they actually mean is that rationalize the what denominator. So rationalization actually means after everything that you do, you have to make sure that the denominator of this set or this one or this one is a rational number. Okay, so we want to make the denominator a rational number. All right, so this one, we said you find the conjugate surd of the denominator. Here we want to rationalize the denominator, so we find a conjugate surd of the denominator, and then you multiply that conjugate surd of the denominator by both numerator and denominator of our original fractional surd. Okay, here, why do you want to multiply it by that? In our first video of conjugate surd, we said we point out, or we said something about um, addition, subtraction, and multiplication of conjugate surds. Okay, we said that when you add two conjugate surd and the surd, you get some results, if you remember. And we also said that the multiplication of every surd on and its what conjugate surd is a rational number. That is why you want to multiply the down here, the conjugate surd of the down here, by the, what do I call it? If sorry, let me take this again. That's why I want to multiply the surd in the denominator by a conjugate surd, so that at the end you get a rational number here. In so doing, you have to make sure that you are doing the same thing to the top, because we can't destroy anything here. In mathematics, whatever you do, you have to make sure that it doesn't affect your expression that you have, or the original expression. So here, look at here, this thing that is here is the same thing here. Okay, so if I point the whole of this over this in a calculator, it will give me 1. So in a sense, it's like the whole of this times 1, and it's nothing. I'll get back this. But here we want to make sure that here is not a surd. It's a rational number. That's why we introduce something that we call this multiplying both numerator and denominator by the conjugate surd of this. Okay, so in doing so, you multiply this by the whole of this. That is how you multiply fractions. You multiply the numerator of one fraction, to the numerator of the other fraction, then you multiply the denominator to the denominator of the other fraction. Multiplication of surd. We've done this in our first video, so hope you understand. And this will multiply this, then this will multiply that. So that is how you expand. Now, by here, because something difference of 2 square, it happens when you have two expressions multiplying each other. Then those expressions, the only terms that are there is what? Only two terms. That is, I mean this and this only. And then the sign that is changing them is what? Minus and plus. Then even if the plus is here and the minus is here, this works. Then you take one of them, you square it, minus the square of the other one. Okay, so you multiplying this is what you get. I've done multiplication of surd. Let me repeat it here. You can multiply the number here to the number in front of the surd and you get 15. Multiply this with this, and since there's a square root here and a square root here, I can multiply the square roots, so it becomes square root of 2 times 2. Here the 2 here will multiply this, and I'll bring my 3. And doing so, here the square of this is that 25, the square of this is 2. And after everything, you compute everything clearly or neatly, then this is what you get. And you get this. You can point the whole of this on a calculator and it will give you this. But I just want to know how the calculator solve this. Okay, because in some textbooks or some lecturers and some teachers, they can give you a question in the form of variable form, or in a variable form that you won't see numbers. You will see, let's say, a minus something, then you know how to do it. Okay, very cool, right? So if I want to rationalize this, the same thing that this goes, you find the conjugate surd of this, and that is 4 plus what? Square root of 5. Then you multiply both numerator and denominator by the conjugate surd of the denominator. So in doing so, this is what you get. Multiplying here, there is a difference of 2 square here. Okay, I hope you can see. 4 is here, 4 is here, root 5 is here, root 5 is here, but the only sign is what? Plus and minus. So I take one of them, I square it, I take this one, I square it, then I subtract. Pretty cool, right? So doing everything, this is what you get, and this is what you get here. The reason why you separate it, when you separate the number parts and leave it like, you see this, we have 4 minus something. Okay, so we want to get a surd in terms of number plus something times surd. Okay, so it becomes, if you have a fraction and the only thing separating them is either plus or minus, I can take one of the numerator, divide by the denominator, then I add or subtract. Here there is an addition here, so I add to this over this, and this over this. Square root of 5 over 11 can be rewritten as 1 over 11 times square root of 5. This is cool, right? That is the solution to the second one. So the third one, you find the conjugate surd of the denominator, and that is square root of 3 minus square root of 2. So that I multiply by the top and the down of the original fractional surd. So now going through all these and this, okay, after multiplying everything, this is what you get. Please go through this step by step and you really understand. Okay, I hope you can do this times that will give me 3, or this times this. Let me start from this times this will give me 3, and this times this will give me, this is a negative already, so negative, then square root of the whole of 3 times 2, which will be 6, and this times that, I'll get the same thing, negative square root of what? 3 times 2, which will give me 6. Then this times that, I'll give what? Positive square root of 2 or square root of 2 times 2, which will give me 2. Here I take, we said difference of 2 square, the same thing here, same thing here, same thing, but here is minus, here is plus. Like I said, even if the minus is first and the plus is here, you can use it. If the plus is also here and the minus is here, you can use the difference of 2 square. So almost all the time in rationalization, the denominator always takes difference of 2 square, and that is it. So this here, the denominator of this whole set is 1, and we don't write anything, any number divided by 1 is the same number, so we don't write. So that is why we just left it like this. And you can see that for all the examples that we solve, after everything, the denominator becomes just a number or a rational number. So that is our interest. Okay, last one, I have this here. Mind you, you can't start from rationalizing this, because there is a square here. So our task is to expand this and write it like this. After that, we multiply, and then after multiplication, we do a summation, okay, of set. If subtraction holds, then you subtract as well. So after everything, this is what you get. So this said fractional set can be simplified as this. We didn't do anything, we just expanded the denominator, and this is what you got. We had. So after that, rationalizing this, you said you find the conjugate set of what? The denominator, and that is this. Multiply by both numerator and denominator of our original set. And doing so one times this will give me that. This times this, I have this. There is a difference of 2 square here, okay? Same thing is here, same thing, same thing, same thing, but plus and minus. So I take the first one, square it, minus the second one, square. And this is what I had. If I want to square this, okay, in indices, I have a video on indices, so you can go and check about it. You can take the first one. Once this and this are multiplying, I can take this one and square it, take this one and square it. Okay, this is how it works. Then 4 square is 16, so becomes 2 square is 4, square root of 3 square is 3, so 4 times 3 becomes what? 12. So I have this. Simplifying everything, this is what you get. And you want to separate the number part and the square, the said part. It becomes 4 over 4, which is 1. 2 over 4, it becomes 1 over 2, square root of 3. I hope you understand it, right? So there are some key notes you should note. When one set is present, this is how you go about it. That is, the denominator has one set, something over this. Here, the Q can be a set or it can be anything, but what we are interested in is how to rationalize the denominator. And this is how you go about it. You just change the sign here, multiply by both numerator and denominator, and then you simplify, okay? And this is how this one too goes. So a question can come a question can come in this form, that this over this rationalizes, okay? That's why I just showed you how to do it, but you can actually punch it on a calculator and you get. But what if the question comes in terms of variables? How do you do it? So that's why you should know all these. Okay, thank you, and subscribe to the channel for more videos, because in this channel, that is understanding maths, we are diving into mathematics, understanding what is happening in the mathematics. Thank you once again, and don't forget to subscribe to my channel for more videos. And in our next video, we talk about equality of